This is past paper 2015, paper 1, question 7. A plane is flying horizontally at P at a height of 150 meters above level ground. So 150 meters is the same as 0.15 kilometers. Okay, so you've got to convert it there. Watch that one there, and that's 5 kilometers from its point of origin. So it's going. It's at currently, if it's here, it's -5 using a regular x and y coordinate system. So you have to interpret that. So it begins its descent. So it's 5 kilometers horizontally from the point of touchdown. So the point, using x and y coordinates, it's -x, and the y value is up 0.15, making sure that everything is in kilometers. Okay. The plane lands horizontally at O. Okay, fine. So taking O as the origin, right? This is where it began here. Approximately describes the plane where f of x is equal to 0.0024 x cubed plus 0.018 x squared plus cx plus d. X ranges from -5, which is here, to 0. So that's the x range, goes from 0 back to -5. Both f and x are measured in kilometers. So they gave you 150 there. You would have had to convert that. They already say it in there. So just be careful there. Show that d is equal to 0. Okay, well, we have this equation here, which is this flight path here, and the origin, which is 0, 0, is a point on that line. So all I have to do is put 0 into there. F of x, of course, is the y. Y is equal to this. So if I put in the x as 0 there, and cx, that's also 0, and that's 0, then I can prove that d is equal to 0, which is fairly straightforward. So we've got the equation, which is f of x equal to 0.0024 x cubed plus 0.018 x squared plus cx plus d. So that's the same as y is equal to 0.0024 x cubed plus 0.018 x squared plus cx plus d. So that goes to 0. That's the 0, 0, putting that in there. So y is 0 and the x is 0. So you get 0.0024 x, that's 0 cubed, plus 0.018 to 0 squared, plus c by 0 plus d. That goes to 0, that goes to 0, c by 0 goes to 0, and you get d. So you get 0 is equal to d, 0 is equal to d, or d is equal to 0. So that proves that. Using the fact that P is the point -5.15, which is there, so that's 0.15 up, -5 back, so the x coordinate is -5 and it's 0.15 up, show that C is equal to 0. So you got to take the equation, you got y is equal to 0.0024 x cubed plus 0.018 x squared plus cx plus d. We've proven d is equal to 0, so there's 0. We have a point on the line at x is -5 and y is 0.15. So y goes at 0.15, 0.0024 by the x, which is -5 cubed, plus 0.018 by the -5 squared, so the -5 squared, x is -5, plus c by x, which is -5, and the d is 0. So we get 0.15 is equal to 0.0024, -5 cubed is -125, plus 0.018, -5 squared is 25, -5c. 0.15 is equal to, now 0.0024 multiplied by -125 works out at -0.3. 0.018 by 25 is 0.45, and you've got the -5c. So minus 0.15, bring the -0.3 over, you get 0.15 plus 0.3, bring the 0.45 over, you get -0.45, and that is equal to -5c. That they add them all up, you get 0 is equal to -5c, therefore 0 is equal to c, therefore c is equal to 0. Find the value of f dash x, the derivative of f of x, when x is equal to -4. So I've got to get the derivative and then put the x value to be -4. So the derivative of the equation is, so f of x is 0.0024 by x cubed plus 0.018 by x squared. C was 0 and D was 0, so they're gone. So we just have to take the differentiate that. That would be 3 by 0.024 by x squared, because you take 1 minus there and that. And then 2 by 0.08 by x to the power of 1. Okay, so you've got, that's it there, that's the derivative. So f dash of minus 4, the derivative evaluated when x is equal to minus 4, is equal to 3 by 0.0024 by minus 4 squared plus 2 by 0.018 by minus 4. That gives 3 by 0.0024 gives 0.0072, and 4 minus 4 squared is 16, and 2 by 0.018 gives 0.036, and that's multiplied by minus 4. That gives 16 by 0.0072 is 0.1152, and minus 4 by 0.036 is minus 0.144, and that is equal to f dash of minus 4 is equal to minus 0.0288. So I've evaluated the derivative at x is equal to minus 4. So that means that the derivative is the slope of the tangent to the line at any point. So we're saying the derivative at minus 4 is the slope of the line, slope of the tangent to that point there. So that's what we've just calculated, the slope of the tangent. That is the derivative, as we know. Okay, so the slope is minus 0.0288, which we've just evaluated that. It's going this way, left, so it's a negative slope, but the angle in there doesn't really, is oblivious to that, right? So just keep that in mind. So we've got f dash of minus 4 is equal to minus 0.0288. They want, so we've just done that, right? That's evaluated. Find the right, okay, so that's B there, that's done there. Then the next part of it was use your answer in part B to find the angle at which the plane is descending when it is 4 kilometers from the touchdown, right? So what we've just evaluated there, as I pointed out, we've got the slope when x is minus when x is minus 4, and they've just said when it's 4 kilometers from touchdown. So that means when x is minus 4, what is its approach angle? So we've got the derivative at this point. So the approach angle is the slope of this tangent at that point. So we've got to get the angle in there. So we have this and this. That's the tangent there, skims there, and then you've got that and that. So y over x is this angle in here, which is the slope, right? We know that's the slope, so we know we need to find the angle, right? So we've got to get the inverse, and tan of y over x is equal to that. So the tan of y over x is equal to this angle in here. That's the tangent, right? So that's the angle. We need that, and we know what the slope of this is, which is equal to 0.0288. So you just have to take the inverse tan of that, and then you're going to get the angle, right? So we've got the slope of is 0.0288. Tan theta is equal to 0.0288. So theta is equal to inverse tan of 0.0288, which is 1.644966 degrees, and to the nearest degree it's 2 degrees. So it's coming in at 2 degrees. To the nearest degree. Show that minus 2.5 and 0.075 is the point of inflection of the curve y is equal to f of x. Well, the point of inflection is when the derivative, the second derivative, is equal to 0, right? Now we have the first derivative. We've just calculated the first derivative there. F that we calculated it there. F dash of x is 3 by 0.0024 by x squared plus 2 by 0.018 by x. Now I've got to do it again and then set it equal to 0 and then find the x coordinates. So f dash x is equal to 3 by 0.0024 x squared plus 2 by 0.018 by x. Point of inflection is when f dash dash x is equal to 0. So I need to take the derivative again of this. So f dash dash x is equal to 2 by 2 by 3 by 0.0024 by x. So that, 2 minus 1 is 1. And then, the derivative of 2x is 2. The derivative of 2 by 0.02 multiplied by 0.018 is 2 multiplied by 0.018. So we get 6 by 0.0024x plus 2 by 0.018 is 0.036, and that gives 0.0144x. 6 by 0.0024 is 0.0144 by x, plus 0.036 is equal to 0. 0.0144x is equal to minus 0.036, bringing that across. X is equal to minus 0.036 divided by 0.0144, which is equal to minus 2.5. So when x, the point of inflection, the second derivative occurs when x is equal to minus 2.5, but we need to know the y coordinate of that, so we have to go back to the original equation for this. So x is equal to minus 2.5, y is equal to 0.0024 by minus 2.5 cubed, this is the original equation, plus 0.018 by minus 2.5 squared. C and D were 0. So y is equal to 0.0024 by 2.5 cubed is, or minus 2.5 cubed is minus 15.625, and 0.018 multiplied minus 2.5 squared is 6.25. So I get 0.0024 multiplied by minus 15.625 is minus 0.0375, and 0.018 by 6.25 is 0.1125. So 0.0375 plus 0.1125 is equal to 0.075. So when x is minus 2.5, y is equal to 0.075, and that's the point of inflection. That's when it's changing. It's coming down, and then it's smoothing out. So it's around here somewhere. That's the point of inflection. It doesn't really look like it's a point of inflection, but it is. Okay. So y is the point of inflection for the curve there, and that's been proven. Okay. Then we've got a if xy is a point on the curve, verify that minus x minus y and minus y plus 0.15 is also a point on that curve. So I just got to put that point into the original equation and see if I get the original equation back out again, right? If it balances up, right? So we have the original equation, which is f of x is equal to 0.0024x cubed plus 0.018x squared. Then we have that f of x is y, right? So y is equal to 0.0024x cubed plus 0.018x squared. And I'm going to take out a factor here because it's going to be easier. So I'll take out an x squared. So x squared into 0.0024x plus 0.018. Okay. Then I plug in our values. Y is minus y plus 0.15. You got to think of that as being a number. I know that y can confuse you, but it's really, that's just a number I'm putting in. So it's minus y plus 0.15. Y is that. It just happens to have another y, which confuses you. Okay. So, and we have x is x. It becomes minus x minus 5 squared. So that there becomes minus x minus 5 squared, and into 0.002524 by into x, which is minus x minus 5 plus the 0.018. So square this out, you get x squared plus 25 plus 10x, and that goes into 0.0024 by minus x, which is minus 0.0024x, and 0.0024 by minus 5 is minus 0.012, and that's plus 0.018, right? So you get that again, x squared plus 25 plus 10x into minus 0.0024x, that comes down, and minus 0.012, negative 0.012, plus 0.018 is positive 0.006. Multiplying that out, you get x squared by 0.0024x gives you a negative 0.0024x cubed. That's negative 0.0024x. X squared by 0.006 gives positive 0.006x squared. Then 25 by this is 25 gives 25 by negative 0.0024 gives negative 0.06x. 25 by 0.006 is positive 0.15. 10x by this is 0.024x squared. The x becomes x squared, and the 10 by that moves that, so it goes 0.024x squared, and the 10x by 0.006 gives 0.06x, right? So we have a minus 0.06x and a positive 0.06x, so they will go, okay? You will then have 0.0024x cubed, negative 0.0024x cubed, and you have 0.006x squared positive minus 0.024x squared, which gives minus 0.018x squared plus the 0.15. You have and that's y minus y plus 0.5 is equal to that. So you get minus y plus 0.5 is equal to minus 0.0024x cubed minus 0.018x squared plus 0.15. Minus y is equal to minus 0.0024x cubed minus 0.018x squared plus 0.15 minus 0.15, which will get cancelled, right? So then we have minus y is equal to minus 0.0024x cubed minus 0.018x squared. Y is equal to 0.0024x cubed plus 0.018x squared, which is the original equation. So that proves that it's on the line. Right? Balances. Find the image of minus x minus 5 and minus y plus 0.15 under symmetry in the point of inflection, right? So under symmetry on the point of inflection, that's the point of inflection. We worked that out earlier on. That is minus 2.5 and 0.075. That's that point. And we have another point. They're saying that it's minus x minus 5 and minus y plus 0.15. Now you just got to treat them as numbers, though they don't look like it. So the point under symmetry in the point of inflection means that the distance from here, that's the point of inflection, that's the point. So we go from the point to the point of inflection, then from that point we go the same. If that we need that distance there has to be the same as this distance there, okay? So we go from there to there and there to there. So we got to find the distance from there to there for each coordinate, for the x and the y, and then we can do it that way, okay? So we need to get the distance. Let's say we'll just deal with the x's first. So we got to get the distance from minus 2.5 to this one, minus x minus 5, okay? That's that x coordinates only. So we get minus 2.5 minus x minus 5. So this distance, the x coordinate, the dx, right? I'm going to call it dx. That's actually confusing, dy dx. I'm calling it the distance of x, right? Let's put a bracket around it. You get minus 2.5 minus x minus 5. Minus 2.5, that becomes plus x, and minus by minus 5 is plus 5. So you get x plus 2.5. So from there to there, the x coordinate changes by x plus 2.5. That's that distance there, and I just need to work out the y bit as well, the y jump. So it'll be 0.075 minus this, 0.075 minus y plus 0.15. So it's 0.075 and minus by minus becomes plus, so it's plus y and minus 0.15. So it's 0.075 plus y minus 0.15. That becomes minus 0.075 plus y, or y minus 0.075. So the y coordinate from there to there would change by y minus 0.075. That's like a value, you know, it's a distance. So now we need to know what this is here, this point here. Well, I've actually put the answer in, but we need to know how we get that. So we got to add to the point minus 2.5, you know, an x amount, which we worked out as a jumps x plus 2.5. It's the same jump from there to there. It jumped from there to there, then it's got to jump the same distance. So you got to go this bit minus 2.5 plus the x plus 2.5. That's it, like a number. You got to treat it as just like a number, right? Though it has an x in it, which kind of is confusing. So it's minus 2.5 plus x plus 2.5. So it's minus 2.5 plus x plus 2.5 and the minus 2.5 and the 2.5 cancel out, you get x. So that translates, it works out at x. And then we do the same thing, we got 0.075 and it jumps plus y minus 0.075. Jumps that amount, right? So it's 0.075 plus y minus 0.075, which is equal to y. So it's y, it ends up as y. So this point jumps the same amount, this distance and this distance are the same. It ends up as x and y.